We are asked to use electron dot structures to predict the formulas of ionic compounds. Now, on your test, we are not going to tell you that these are ionic compounds. We would have you figure that out on your own. A big clue is that you recognize that potassium and magnesium are both metals, and oxygen and nitrogen are nonmetals. Sorry, I meant to write nonmetal. So that's a big clue when you have a metal and a nonmetal that you're going to get an ionic compound, which means you're going to need ionic bonds. That's where the metal loses its electrons and the nonmetal gains it. So it's a transfer of electrons. Let's take a look at A a little closer. Potassium is over here. So my periodic table doesn't have group numbers, but yours will. The last digit in the group number will tell you the number of valence electrons. That's just a short way to do it without having to draw however way you would do this, energy diagrams or electron configurations. So potassium has one valence electron, and that's what these Lewis dots show, just the valence electrons. And oxygen over here, we know that's a nonmetal. So oxygen is going to be, this would be group 16. So that's 6 valence electrons. You might be able to look at this and say, well, this guy can only give 1. This guy only wants to take 2. We're going to need another potassium. And if you can see that, that's great. Now, I'm going to show you the crisscross method because it can get trickier than what you have right here. So I'll just try to show you the same way every time. So you want to get the charge, and that's potassium is going to make a 1 positive charge, because when you're making an ionic compound, these are elements in the first column are going to be 1 positive. These are going to be 2 positive, and pretty much just aluminum here is going to be 3 positive. These don't form ionic bonds, and 1 negative, 2 negative, and 3 negative. And for like oxygen, it's always going to want to gain 2 electrons, which is why it's 2 negative. So back to the charges. Potassium is going to form a 1 positive charge, and then oxygen is going to form a 2 negative charge. And what we're going to do is just crisscross the numbers of these charges to the subscript of the other element, right? And so what you get is potassium is going to have subscript of 2, and oxygen is going to have a subscript of 1, and we don't write 1. So this here is called your formula unit. So now we can draw this. I'm going to just continue this down here. So we know we're going to need 2 potassiums. I'm just going to rewrite that. It's going to have 2 potassiums and 1 oxygen. All right, so I'm going to draw my 2 potassiums, and I'll draw my 1 oxygen with the 6 valence electrons. I'm going to draw this here to show you the transfer of that electron, and you can see the blue one came from the potassium. What you get are cations now. So I'm emphasizing that with the brackets. That's going to be a 1 positive charge. I got another one right there. And then I have my oxygen emphasizing the valence action, 2 negative. And there's my ionic bonds. It's the electrostatic attractions between the oppositely charged ions, the cations and the anions. All right, so on a test you might want to rewrite this like that. Sorry, that meant a negative sign. Circle your final answer. There we go. Oh no, we're not done. All right, so the next one I'll do just a little bit faster. All right, magnesium is right over there. I'm just going to go right to the formula unit. All right, magnesium, we know that's going to have a 2 positive charge. So there's magnesium. All right, nitrogen right over here. I know that's going to have a 3 negative charge. Okay, because it has 5 valence electrons. It's going to want to gain 3. So it's going to be magnesium, 2 positive, nitrogen, 3 negative. So I'm going to crisscross the numbers. Don't bring the charges down. The charges don't belong downstairs. All right, so the formula unit for a compound consisting of magnesium and nitrogen ions is going to be Mg3N2. So that's your formula unit. So now we know how many to draw. I'm going to need a little more room. Stretchy. All right, I'm going to need 3 magnesiums. Each of them has 2 valence electrons because it's in group 2. And then I'm going to have 2 nitrogens. Each has 5 valence electrons. because that's in group 15. Last digit of the group number will tell you the number of valence electrons. All right, that guy goes there, that guy goes there, that goes there. You can put 2 dots on each side to get that octet. Octet. That one goes there. Pair up with that electron. Pair up with that. Here we go. That's a little better visually. There. There. Everybody's happy. Octet rule. They all look like neon. All right. So now, what else did it ask us to do? Oh, see. Okay. Right. All right. So now, what's it look like after it does all that? It's going to look like this. Magnesium. It lost 2 electrons, so now it's 2 positive. Give myself a little more room. Put a bracket here just to emphasize that these are cations now. All right, and then there's 3 of them. And then nitride, it's no longer nitrogen. That's the one that gained the 3 electrons. So I'm going to emphasize that here. The valence action. And it gained 3, so that's 3 negative, and there's 2 of them. Voila.